$1 billion spent on 4 used airplanes. That's what Boeing paid to turn 4 second-hand 747-400s, jets that had already flown for Air China, Malaysian Airlines, and China Airlines, into freighters that no other company on the planet is allowed to operate. On the other side of the Atlantic, Airbus spent almost exactly the same, €1 billion, except Airbus didn't convert old jets. It built 6 brand new aircraft from scratch. Same problem, same budget. Two completely opposite philosophies. And here's the interesting part. In 2026, one of those 2 super freighters fleets is already being parked in a museum. The other one is still flying every single day, almost 20 years after it left the factory. Except the fleet heading to the museum isn't the one you'd expect. So which one was actually the better solution? And which one will still be standing when the next generation of aircraft arrives? Neither Boeing nor Airbus wanted to build a superfreighter. They were forced into it. And they were forced into it precisely because both did the exact thing investors loved back in the 2000s, spread production across the world to cut cost and split risk.
60 flights a week between 11 different sites, with a high level of operational reliability. This shows what an important part the Belugas play in the production of Airbus aircraft.
Boeing went even further and spread the 787 across 3 continents: wings in Japan, fuselage barrels in Italy, structures in South Korea, final assembly in the United States. The success of the strategy created the problem. The cheaper the parts got to build, the more expensive they got to move. A shipping container doesn't solve this. It's money sitting still, bleeding out on the balance sheet. That's where the 2 companies made opposite calls. Airbus decided to build a new airplane designed from scratch on top of the A330-200 airframe to become the backbone of an entire European industrial network, the Beluga XL. Boeing decided to buy 4 used 747-400s on the open market and cut them in half, the Dreamlifter. One bet on a platform, the other bet on a conversion, and both choices send the bill at completely different moments in history. Hold on to those 3 axes, because the winner changes on every single one. On the first axis, the answer is straight, and it surprises most people. They both win, just in different categories. The Dreamlifter wins on weight. The donor 747-400 delivers a structure capable of hauling roughly 113 tons of cargo. The Beluga XL stops at 51 tons. In raw numbers, the American carries more than double the European. But weight in this business is almost irrelevant. The cargo these airplanes move is bulky and light. A composite wing takes up the space of a 2-story building and weighs a fraction of what the structure could handle. It's like moving house carrying nothing but pillows. The truck fills up long before it gets heavy. And on volume, the math flips. The Dreamlifter offers 65,000 cubic feet. 1,840 cubic meters, already 3 times the usable volume of a standard 747-400 freighter. The Beluga XL clears 78,000 cubic feet, more than 2,200 cubic meters, roughly 20% more internal space in the airplane that carries half the weight. The Beluga XL swallows cargo up to 63 meters long and takes 2 30-meter A350 wings at the same time, something the original Beluga could never do. It was sized with 30% more transport capacity than its predecessor for exactly that reason. So the scoreboard on Axis 1 is clear. The Dreamlifter wins on the scale, the Beluga XL wins on the tape measure. And since this business is about moving volume, the tape measure is worth more than the scale. On the second axis, the European pulls away, and it pulls away for a reason that never shows up on a spec sheet. The Beluga XL isn't an airplane, it's a system. 11 destinations across Europe with infrastructure built to order. Dedicated loading platforms, reinforced pavements, dedicated crews, procedures designed so the airplane spends the least possible time standing still. Airbus didn't buy flight capacity, it bought ground time. Think of a Formula One pit stop next to a tire change at a neighborhood garage. Same car, everything around it is different. That matters because the European assembly line has turned into a monster of scale. In 2025, Airbus delivered 456 A320neo family aircraft and runs that family in the range of 50 units a month. Every one of those airplanes depends on parts that cross 4 countries before they become an aircraft. One day of delay on the internal air bridge doesn't delay a flight, it delays a delivery. The Dreamlifter plays a different game. It doesn't connect 11 factories sitting close together, it crosses the Pacific. With a range in the 7,800-kilometer class and an entire logistics chain built on top of 4 aircraft. 4, that's the number that haunts the program. If one Dreamlifter goes down for heavy maintenance, Boeing loses 25% of its 787 transport capacity in a single stroke. There's no panic button to hit. There's no reserve fleet. And here's the moment the European strategy proved it bleeds too. In January 2022, Airbus announced something that looked like easy money. With the Beluga XLs taking over the internal network, the old Belugas, the Beluga STs, based on the A300-600, would be free. Why not sell them as an outsized cargo service to outside customers? Airbus Beluga Transport was born. Whole helicopters moved without disassembly, satellites, giant industrial equipment. The global outsized cargo market was hot, and it had a huge hole left behind by the destruction of the Antonov AM-225 in Ukraine. The operation was shut down in early 2025. The reason is a masterclass in aviation economics. Not enough demand, operating costs too high, limited range, and loading requirements so specific that the customer needed special infrastructure at the destination. Against an Antonov AN-124, which carries more, flies farther, and operates just about anywhere, the Beluga didn't close the math. The strangest-looking airplane in the world worked perfectly for one mission, and it couldn't make money outside of it. The last operational Beluga ST flight took place on September 17, 2025. In January 2026, the first airframe was retired for good in Broughton in the United Kingdom, where it will become an education center. Now look at the raw engineering of the two, because the difference in philosophy shows up even in the way the door opens. The Dreamlifter loads through the back. The entire tail of the airplane swings sideways, a swingtail in the jargon. Except, unlike the 747 freighter, which lifts its own nose with its own hydraulic system, the Dreamlifter has no power of its own to do it. The tail is opened and closed by a modified container handling truck, then locked to the fuselage by 21 electric actuators. An airplane with a maximum takeoff weight above 875,000 pounds, around 397 tons, that needs a borrowed truck to open itself. That's how Boeing saved between 20 and 40% on total project cost, which still landed close to $1 billion. The conversion was done in Taiwan by Evergreen Aviation Technologies. The first Dreamlifter flew on September 9, 2006, just 375 working days after the modifications began. Fast, functional, cheap for what it delivers. And there's a clause almost nobody knows about. The 747-400 LCF certification only allows operation in Boeing service. It's flown by Atlas Air under contract, and it cannot be chartered to anyone else. It isn't a freighter. It's an internal Boeing tool. On the European side, the Beluga XL was born with a lowered cockpit, an enlarged cargo bay structure, a redesigned rear and tail section, and its own loading systems, assembled in Toulouse. Program launched in November 2014, first flight in 2018, entry into service in January 2020. The 878 is accelerating. Boeing delivered 88 Dreamliners in 2025 and is working toward a rate of 8 aircraft a month, aiming for 10 a month by the end of 2026. The company is standing up a second final assembly line in South Carolina with long-term potential of 14 to 16 airplanes a month. Add to that the most expensive move of recent years, Boeing reabsorbed Spirit Aerosystems in an all-stock transaction valued at $4.7 billion, taking back direct control of structures it had outsourced 2 decades earlier. Meanwhile, Airbus has the opposite problem. The A350 has been stuck around 6 units a month against a target of 10 in 2026 and 12 by 2028. The 6-aircraft Beluga XL fleet was sized for a production ramp that hasn't arrived yet. One of them has the right airplane and stalled demand. The other has demand climbing and only 4 20-year-old aircraft to serve it. So go back to the original question, now with every number on the table. Which was the better solution to the original problem? Boeing solved it faster and cheaper. 4 used airplanes, $1 billion, double the weight capacity, an intercontinental operation running since 2007 that has never stopped. But who's better prepared for the next problem is a different story. In May 2025, Airbus finished the first wing set for the A350F, the new 111-ton freighter due to enter service in 2027. Those wings left Broughton inside a Beluga XL headed for Bremen and from there to Toulouse. The new airplane is already carrying the parts of an airplane that doesn't exist yet. That's the point. Airbus didn't build a transporter. It built the ability to upgrade itself. When the product grew, it swapped the tool and sent the old one to a museum. No drama, no trying to squeeze 10 more years out of a spent asset. Maybe the real competition was never between two weird-looking freighters. Maybe it's between two ways of thinking about industrial risk. Buy cheap and hope the problem never changes, or pay up for the right to change along with it. If you had $1 billion to spend today, would you buy 4 used airplanes that solve today's problem, or 6 new airplanes that solve the problem of 2040? Drop a comment below with which one you think will be the last one still flying.